Hello, everyone. During today's webinar, I'll explain workflow for real-time tracking of digital procedure in Exebenus Pulse application. Before we get going, a brief introduction. I'm Namit Singh. I've been working with Exebenus for past couple of years as well digitalization manager, involved in research and development and software implementation. I have petroleum engineering background, and I've worked in office and field-based engineering positions with both operating companies and service providers for approx 11 years. And while working as a drilling and completions engineer and supervisor, preparation and tracking of these operational procedures was one of my main job responsibilities. Here's a list of key takeaways from today's demo. I'll focus on the run module of Exebenus Pulse application. In simple terms, run module tracks the execution of operation procedures at the rig site. Real-time tracking of a procedure allows everyone to have visibility of ongoing operation, helping office team to track operational status. Also, run module projects a dynamic procedure where deviations or changes can be handled on the fly as per operational requirement. Lastly, it provides historical operations footprint in the database, and this information can be used for benchmarking of template procedures. So without further ado, I'll dive into the application to get started with the demo. For today's demo, I've selected a template procedure for wellbore cleanout activity. And the procedure displayed here is picked from template set available in our software library for various types of operations. As our first example, procedure being performed comprises of a set of manual activities. In this case, driller will manually acknowledge these start and stop timings in the software. After I've shown this example, we'll look at a liner setting sequence, which would be recognized from real-time data stream without requiring any intervention from the driller or any other end user. So the workflow being demonstrated now of manual activity tracking, where driller would initiate start and stop timestamps digitally for each activity. It's quite similar to keeping track of activity timings in a driller's tally book. Based on this data synchronization and connectivity setup, updated information would be visible at other locations logged into this active procedure, meaning as soon as someone signs off a check digitally, it would be visible to all other users using this application. The display you see here, it's the driller's view at the start of any procedure on the rig, where we have detailed version of a procedure, as I mentioned, for a wellbore cleanout activity. And worth mentioning that apart from driller, everyone else, including office personnel, will have a read-only view of this screen for operations tracking. Before we start running this procedure as for real-time operations, let's review the information filled out in the overview and pre-operations tab. So the information displayed here is set up during the planning phase of this procedure, and it does not require editing from driller or the rig personnel. It has, starting with the basic header information, status and objectives defined for our operational activity. Operation constraints listed here could be based on the equipment or operational limitations. And finally, we have section for attachments linked to this procedure. It seems like I have attached too many, so it's a backup of the attachments. And this information can be accessed by driller at any point while the procedure is being run. Next, I'll show you the pre-operations tab. And this has been set up with some example insights for a wellbore cleanout procedure. At the rig site, person responsible for different checks will mark them complete prior to start of operational steps. And users at other locations would be able to view once a check has been marked as done. And user-related information like the position approving it, and the timestamp are stored in the application database for these pre-operation checks. So it could have information like equipment checks, or if there are any ROV activities, as you see here for offshore operations. This would also be covered under our pre-operations tab. For next example, let's look at the risk object related to the well control event. In our software, risk element is set up as per the WITSML standard, and that's something we can import from any external application like EDM or Spotfire. You will notice the selected risk object has been added as a standard insight, meaning it would be applicable to all assets across the organization. We can then link a contingency procedure to this risk object in case driller needs to use it in case of deviation from plan. So I've assigned a well control procedure to this particular risk object here. And to gain further understanding of our insights concept, I would highly encourage you to visit our YouTube channel. Next, I'll switch to the operations tab. This is the view operation personnel would be using the most. And since I'm demonstrating the manual run first, I'll have to start running this procedure by pressing Start button at the bottom right corner of our screen. Now, acting as driller, I'll initiate our first procedure step, quite standard manual activity for most rig operations, pre-job safety meeting. So insights associated with different procedure steps pretty much follow the same logic as I explained for pre-operation tab. Once these insights are marked done, approving position and timestamp are stored in the application database, and everyone will be able to view updated information. So I'll go ahead and stop this procedure step for pre-job safety meeting. Obviously, in real time, it's going to be a bit longer. Next, I'll initiate procedure step involving 3 sub-activities for setting a lockdown sleeve inside wellhead assembly, starting with first sub-activity to prepare and make up lockdown sleeve assembly. So I'll let it run for a few seconds before we move on to our next sub-activity within this procedure step. And you'll notice once I press the stop button, the activity is marked completed with a green tick. That's the status indicator for this particular activity, and the timestamp for the activity is displayed next to it. So I'll do the same for next couple of sub-activities within this procedure step. And lastly, for testing this lockdown sleeve. And in practical application, if there is any procedure step or a sub-activity within this procedure step that needs to be skipped, driller can use this particular functionality, skip this function in order to jump onto the next procedure step. And I'll go back to the procedure step we covered. And in the upcoming version of Run module, a user would be able to add operational parameter like pressure test value, which you might notice has been added as rich text here. And these operational parameters could be things like weight on bed, running speed, etc. And this is an existing feature for set of automated activities like drilling and reaming, but we are extending this functionality to manual activities as well. Next, I'll show you the comments section through which an operation team can communicate in real time if required. For example, I've added a comment here while the procedure was in approved state. And now my colleague, Jan Kura, will go in and reply something nice in real time. So he's acting as the company man and confirming what I had asked. So, yeah. And I'll emphasize again that apart from driller, everyone else, including office personnel, will have read-only access of the screen for operations tracking, except for the ability to communicate through this comments section, which I've just shown you. Next, let's look at the workflow for managing deviations from procedure. One way to handle a deviation would be to link contingency procedure to any given procedure step. And as a user, one needs to anticipate operation deviations in order to have procedure available within the database library. Then we can link these contingency procedure from existing database of template procedures. As an example, I've associated procedure for wireline run in case this lockdown sleeve could not be installed by a drill pipe assembly. And standard or minor changes like a flow check, decision to ream a stand to clear tight spot, and several other changes could be just added on the fly while the procedure is still in active state. And for some instances, these changes might require DSV or office approval based on the workflow we have set up in the run module. So that's a very client-specific configuration. Lastly, there are some views. So it's customized as per the user preference, and you can decide what information you want to view. And I'll show you the time log of different timestamps for the activities we just marked manually completed. So you'll see this is the time log that we have completed, and the clock is still ticking since the procedure status is still active. While we are talking about the active status, I'll briefly explain procedure lifecycle in Exebenus Pulse. The procedure is initiated in a draft status, and it goes through a review process before being set in approved state. And only an approved procedure can be used on the rig and set in an active state. Once procedure has been completed, status will be updated from active to as run, and it could be driller, drilling supervisor, or any other assigned user. They can go in and add lessons learned and best practices. Same could be done during an after action review to identify gaps and further updating the template procedure. So I'll quickly show you the post operations tab. This is where you would go and add your post operation learnings. And as an example, I've added a check here meant for a drilling superintendent to sign off the pressure test charts. And again, I'm signing this check off as any random user, but the application would be configured in a way that only this particular position would be able to sign off the check assigned to them. Lastly, let's look at the data log for one of the completed procedure. This is a short sequence for setting and testing a production packer. And here we have timestamps compiled for all the operation steps and sub-activities within them. And we are implementing export capability for the time log so that the output from time summary can be used either as an automated DDR format or as an input to existing DDR. Next, I'll show you activity recognition for automated sequence, as I mentioned, for a liner setting. So just to explain, any procedure would be a combination of manual and automated steps. And the first sub-activity we see here is a manual step for dropping ball for setting the liner. Please ignore the text saying drop tool. We definitely don't want to drop any tools in the well. I'll run the sequence at 100 times the actual speed in order to cover 2 hours of operational activities. And I'll go ahead and start this. You'll see the procedure is in approved state. We have got a check here that driller needs to perform. And I'll go ahead and start this manual activity, the first one for dropping the ball. And this action will update our procedure status to active. You'll notice the timer has started to keep track of procedure time. I'll stop this one and scroll back to view the start and end times and total duration for our manual activity. And while we are looking at the timestamp, one module is receiving data from XML file and comparing it with the values entered for liner setting sequence in digital procedure. Once it recognizes a machine task completed as planned, we'll see a green tick status indicator next to that particular task. In this case, tasks being performed like increasing flow rate with rig pump for a certain duration. And we have added the actual values in the text box below the procedure step, showing values recorded from XML data. In a second, we'll notice the task specified for keeping flow rate steady for 60 minutes did not happen as planned, and the recorded time was 55 minutes. And same applies for the next task in sequence for reducing the flow rate. That's why we see these yellow exclamation marks next to these tasks as our visual indicator, informing users that if any steps were not executed as per the plan. As we continue running this procedure, one module highlights the procedure step being performed. And this was quite a short sequence, the one I demonstrated now. And upon completion, you see the procedure status change to as run at the top. I would like to show you the tablet view for our run module, showing a structured format of the procedure. And this view is more focused towards user experience aspects for a driller. So it's easy to navigate through it while managing operations. Both tablet as well as desktop view support the responsive design. And in this case, for tablet view, you will notice on the left side, the view driller would have initially, where we have active procedure at the top and all the upcoming procedures which are in the sequence and have approved status, they will be reflected after the active state. On the right side of the screen, it's a structured view of procedure page. We looked at in more detailed version of desktop view. And here we have made sure all operational critical information is available to driller on a tablet version. In this slide, I'll briefly explain software architecture. In this instance, Exebenus Pulse is hosted as a cloud solution. Users at headquarters or different regions and rigs can access the Exebenus Pulse application through web browsers. For run module demonstrated today, we use the XML data stream to validate and track the activities. So to recap, Exebenus Pulse gives the users at the rig site or in the office visibility and operation trackability of ongoing operation to reduce invisible lost time and prevent non-productive time. Procedures generated with Exebenus Pulse are dynamic and easy to update if required. As such, various personnel involved in operations can interact and communicate in context of the ongoing activities. Lastly, historical operations footprint captures lessons learned and best practices for these procedures and deviations, if any, from planned procedures. Thank you for taking the time to join us for this webinar today. If you would like to know what's going on with Exebenus, you can follow us on LinkedIn, and you can also see more videos of Exebenus Pulse on YouTube channel.